a faculty and being a part of industry, what is the general difference in between the way in which the faculty behaves and the way in which an industry person behaves, and how do the learning is different from both of them? Can we just
Definitely. Like yeah, definitely. Because when I was started for the first week, completely it's very different. And where academic, what we are observing about the some formality, some in a formal manner that we are approaching with the students, with the faculty, and doing in a formal way. And here are totally in an informal way. I must say, like they everyone call with their own name, not a sir, not a like Mister, not directly call with the name. चाहे वो like he is HR, he is your team leader, he is your project manager, doesn't matter. They are only looking for your skills, your expertise, and how you can resolve the issue with your specialized logical way that you can resolve it. And these are the just normal like gesture that what I have observed in the primary part. And secondary part, yeah, definitely whenever you come into the industry, must have a prior knowledge about this basic that I already told you. Must have a basic requirement. And third point, yeah, production level thinking. That is again most important for the production level code for that particular product type. Like if I say, like if you want to change, if you want to give the any condition, then simply we are using the if else condition in a simple manner or a simple behavior. But this kind of condition, they are not going to accept it. They are looking something with ternary operators with some number of conditions, more than one ternary operator they are using, and many more things over there actually. So definitely, if you are looking at the 1 point, they are looking at the 4 point after the 5, I can say. And definitely learning each and every day, each and every hour, you are going to learn something, to know something, something new, definitely. And someday, like also happen with me, like what I have realized up to the whole day. Like today, I have not received like something new. Apart from the whole day is 9 hours, this 9, 10 hours is completed, and I have not gained anything. But actually, you are gaining something knowledge, learning from that applications, learning from that product, learning from the technology. So each and everything is going on in your behind, in your backside that you never know. After the completion, you will get the idea that totally a vast and very differential or any another section of this industrial organization that I would like to say sir, here.
It's really wonderful, sir. What is that we do is, with your permission, we will start the session now.
Yeah, sure, sir. Please.
Yes. Gayatri madam, please proceed, ma'am.
Okay, sir. Thank you, sir. Good afternoon to one and all. Welcome to Professor Vaibhav C. Gandhi and all the participants. We are from Department of Computer Science and Engineering, Sri Vishnu Engineering College for Women. First of all, I like to convey my thanks to you join with us to share your knowledge. Before entering the session, first let me introduce about you, sir. It is my honor to introduce Professor V. Vaibhav C. Gandhi. Currently, Professor Vaibhav Gandhi working as software developer at Vadsias Solutions in Vadodara. He completed his bachelor's degree in computer engineering from Gujarat University, and he completed his master's degree in the same field from Gujarat Technological University. Currently, he is pursuing his PhD in the field of machine learning and deep learning in the domain of healthcare from the Gujarat Technological University. He is having more than 9 years of experience in the field of academics and research. He published nearly 20 research papers and book chapters in various reputed national and international journals and conferences. He published three textbooks, and he associated with a number of organizations like ISTE, IAENG, and SDIWC. Finally, his research focused on artificial intelligence, machine learning, and deep learning. So we are very glad to have such empowerment person as resource person in this faculty development program. Sir, now I request you to share your insights in essentials of deep learning in today's era. Professor, please.
Yeah, my voice is audible first of all.
Yes, sir.
Priyanka?
Yes.
Yeah, thank
Yes,
you
sir,
so much.
audible.
Yeah, thank you so much for this wonderful introduction and enlighten me in this wonderful 5 days national level FTP, recent trends in cyber security and artificial intelligence. And it's my privilege and special thanks to Dr. Kiran sir to give me this wonderful opportunity. As we have already discussed, like my journey is belong with the academician of the 10 years. Then, like from the last 4 to 5 months that I'm working as a software engineer in something IT industry, where they belong with some travel industry. And yeah, it's a wonderful and amazing experience for me. That and continuously, and one more further that I would like to add it over here. Recently in the morning session that I have received one like acceptance from my student, like my 3 more research paper that would publish in AAP publication book that is specially for the IoT, smart IoT devices and its application. So, like you can
जहाँ से नाश्ता पानी मिल जाए, जहाँ से
you
नाश्ता
can
पानी मिल जाए।
you can
अरे हमारे ताक सांडे को क्या समझ रखा है तुमने? ताक सांडे सर को क्या समझ रखा है सर आप?
now I would like to move ahead with my presentation, like essential of deep learning in today's era. First of all, I would like to share my screen. My screen is visible.
Yes, sir. Yes, sir. Visible.
I hope that presentation mode is visible to all of you, right?
Yes, sir. It is visible. Please proceed.
Okay, thank you very much. Yeah. So, deep learning in today's era. So, these are the number of agenda that we are going to discuss in today's presentation for the national FDP on recent trends in artificial intelligence and cyber security. First of all, we would like to enlighten with the relationship between the AI, ML, and DL. The basic terminology about the artificial intelligence, machine learning, and deep learning. Then move ahead with the neural network, artificial neural network. Before starting with the ANN, we must have to come to know about this. What is the meaning of this neural network? Then move ahead with the further topic that name about biological neuron. The next mathematical neuron, activation function, and like a summary of that my presentation. Yeah. So my first agenda that we would like to discussion about the relationship between this AI, ML, and DL. So in this new era of the technology, companies and developers around the world are taking about the embracing about artificial intelligence, machine learning, and deep learning. And here through the figure you can see that like AI is an umbrella or the discipline. Yeah, AI is an umbrella, a discipline that basically covers the everything which is related to making the machine smarter and more smarter. Machine learning, basically now talk about this machine learning, then it's commonly used along with the AI, but it's a subset of ultimately a subset of artificial intelligence. Basically, MI referred to the AI system that can self-learn based on the algorithm or the program. That system gets smarter and smarter over a time without the any human intervention. Like so, without the intervention of the human, more smartly and logically, we can perform the operations. Then again, a little bit go inside. Then you can see the deep learning. First of all, that it's a machine learning and applied as large data sets. So most AI involved with this ML as well as deep learning behavior require the consider knowledge. So you can see here that like artificial intelligence, as I mentioned that program basically capable of reasoning, sanctioning, acting, and adaptation. Where you can little bit go inside, like how it is connect with the machine learning. You can see a human interaction. Okay, so as I already suggest you, like smarter and smarter, like behaving machine learning with the AI. So the program or the definition, it would be defined it in the manner that learn and adapt the new fact and functionality for the AI. And a little bit more ahead, like in today's era, like everybody knows about the like robotic surgery. Just a simple example that I am giving over here. Okay, we definitely, most of the people I have heard this name, like every person at their home, like older people, old age people, that having issues of knee issue and many this kind of disease where the robotic surgery is involved in this healthcare direction. So machine learning and the more specification that deep learning is used to tackle a complex issue and construct the intelligent solution. So where the healthcare comes into our mind, definitely it's something intelligent and something smarter and something visible solution which is must be required for this our health. So you can see that how the deep learning connect with machine learning and machine learning is connect with AI. So how AI, ML and DL,
Mute and
how the artificial intelligence, machine learning and deep learning, it is nothing but all the correlated one another and how they are continuously in touch with communicate and performing and giving the best something output about this in the domain of artificial intelligence. So it's not this separation, but it's just a one domain, artificial intelligence, where it come into the machine learning and DL, which is come into the same domain, artificial intelligence. Yes, moving ahead, as discussed about the neural network, artificial neural network. So before going into that neural network, firstly must require to knowing about this a single neural network. Okay, so before starting with this, you can see in this images like something like circles with the blue color, something is come up with the yellow color, and something that is come up with the green color. You can I have mentioned over that like input layer, hidden layer, and the output layer. Yeah. So these are the all the input layer, and these are the output layer. That means basically, definitely, all the people get the idea like input and output, and there will be a between a layer of the hidden layer. Okay, and yeah, each and every node which it must be connected with each other here continuously. So a single neural network, single layer neural network represent the most simple form of a neural network where there is only a one layer of the hidden layer. You can see there is only one hidden layer here that send the weight input to a subsequent layer of the receiving node, or in the some case one receiving node. Example that we are talking about perceptron, that would be written a function based on the input, and again based on a single neuron in the psychology of a human brain. And like little bit more ahead with this single neural network that we have discussed, then move ahead with this deep learning neural network now. So basically, again, it is known as the artificial neural network or the stimulated neural network. As you can suggest, like so many people call as a ANN, SNN. So that is basically it's nothing but a deep learning neural network, or it's a subset of a machine learning. So it is we are not something find out something new apart from this, but it's just basically related with the machine learning part, basically related with the machine learning, or it's a heart of the deep learning algorithm. So the name and a structure are inspired by the human brain. You can see that like let's take an example about the healthcare, as I already told you in the previous slide. Here again come up with the same example like healthcare, human brain. If you are talking about a number of veins which is connected with one another, actually we cannot analyze that which node is connected with which another one. Okay, so the inspired by the human brain, mimicking the way that a biological neuron are single to the one another. So ANN can a millions of neurons connected into the one system that which make it extremely successful at analyzing and even memorizing the various information. The more than one neural network which is connected together, and it is just working as like a human brain. I have taken an example about that part. Now, a little bit move on with this further topic. Yes. Now, biological neuron. So, as we discussed about the neuron, a single neural network, artificial neural network. So, human have made the several attempts to mimic the biological system, and one of them, that is artificial neural network, that is again basically inspired by the biological neural network in the living organism. So, typically this biological neurons are individual cell that is composed of the main body of the cell along with the main tendrils, and that extended from that particular body. So, however, they are very much different in a several ways. For example, bird, like talking about the bird, had inspired the human to create the aeroplane, and for like animal inspired to develop the cars or the any other like similar vehicle that we have developed in our like we are using in our daily routines. So a body or the soma houses that machinery for maintaining a basic cell that name functions and energy processing. Example like DNA containing the nucleus and organelles for the building proteins and processing of sugar as well as the oxygen. So I would like to present the one figure before that part. You can see that as I have discussed here in the tendril and the detendril. Okay, so that's basically two type of tendril. That one is then tendrils and the detendrils, which receive the information from the other neuron and bring it into the cell body, and the axons, which send the information from the cell body to the other neurons. Okay, so this would like to part elaborate through this diagram. You can see that as like discuss about the cell body, or it may be pronounced as the soma. You can see that these are the some cell of our body, and these are the dendrils. These are the veins that you can see over here, and the axon which is connected with this line. You can see that, and these are the synapses. These are the line that you can like just represent it over here. So in the living organism, the brain is the control unit of the neural network, and it is a different subunit that take care of the vision, sense, movement, and the hearing. Like whatever the activity as we are performing, it directly sending a message from the our brain to that particular organ or to particular body part. Like if I want to like pick that thing, then it directly send a message to my hand, like I want to pick that particular object, particular class. Okay, so brain is basically connected with the dense network of a nerve to the rest of the body sensors and actors. Like whatever the task that we are going to like performing, that as I told you, like deep neural network, like artificial neural network, that all the neurons are connected with one another. So similarly, that human brain, which is connected to all the other organs and all the other of the body part. So approximately 10 raised to 11 neuron. Okay, it is a 10 raised to 11 neurons in the brain, and these are the building block of the complete central neural nervous system of the living body. Not in just one sentence that I would like to summarize that part, that you can easily understand, like number of neurons of our human brain which is connected with our organ, our body, and that would be perfecting that acting, sensation, movement, or any task that we want to like perform it. That the message, that the signal basically sent it by this human brain actually. Yeah. So this is about the biological reason and mathematically. Okay. Then move ahead with the in the neuron part, like mathematical neuron first of all. So neural network, and it's basically a type of algorithm which employed into the deep learning task. Neural network, again, it's not any separation, or it's not any different thing that we are like performing, but it again just a simple kind of a typical algorithm which employed into the deep learning task. The reason why they are so popularly are a deep understanding of the data. Means if we're talking about the healthcare or any typical domain that we're talking about, if the cyber security, where the a number of or the any financial data, if you are talking about that, the number of transactions doing in the within a moment, if we are taking about the example of credit card, then Visa card or the Master card, within a second or within a moment, a number of transaction is happening with this card in all over the world, in all over the country, in all over the state. And similarly, if I'm as an industry, as I would like to define it, like a booking system, simplified as I want to declare over there, like a number of booking that can be performed in the same day or in the same part, within a moment, within a second, within an hour, or within a day. Okay, so deep understanding of the data, how that is actually working, which is provided thanks to that peculiar structure, NNS. It means a neural network, indeed, but built in the same way the human brain sensor or human brain neurons. So for creating a mathematically model for the artificial neural network, that theoretically analysis of biological neural network, that is essential, as they have a very close relationship about that part. And this understanding of the brain, a neural network, has opened a horizon for the development of artificial neural network system and adaptive the system that designed to learn and adapt this particular situation and the input. Moreover, like being a flexible in terms of structure and the complexity, they only need about the few basic element to work, and all the exciting stuff, that's something that might be taking them work better, and the inner structure remain as the same, like it cannot be going to be changed. In if I just again recall with the previous one slide, you can see that these are the a number of cells that it's not going to be a change, but these are the vessels and these are the synapses that those are connected with our axons, these are the connected with our body, and giving us the instruction, like you need to move over there, you need to treat this function, you have to vision this function, you have to sense it, you have to movement it, hearing, and many more this part. So this is basically about the mathematically neuron. So you can see that it is not about the only neural network that we're talking about, but if you are going with one by one, like single neural network that we have seen, then after deep neural network or the artificial neural network or the stimulate neural network, you can say, then after biological neural network, then after mathematical and neural. So how they are actually working, and that is ultimately nothing but the understanding, that deep understanding of the data, which basically provide the thanks to that peculiar structure, how the number of data which is connected together and how they are actually working, and how we can predict from the help of those data, and predict about the nearest future as well as the longest future, like within a 6 month, like what can be happen, or what we can see as a result or as a future prediction that if you want to do, or in upcoming future, like what will be the happen due to that part, that we can analyze with the help of this mathematical neuron or this biological neuron. Yeah, so move ahead here from this. Yes, yeah, something looking like a tricky. First of all, you can see this diagram, then it's just a confusion, like it's a maybe someone thinking like it's that we are talking about this deep neural network, artificial intelligence, and something like mathematically structure is obtained over here. You can see that, but it is nothing but just a human brain, how they are connected with one another, with our organ, with our body part, and simply that would be like simplified with this diagram. You can see these are the number of input section. You can see x1, that just given a name as the x1, x2, xn, up to it goes on, like okay. And that I have already mentioned, that you can see that inputs. Then next you can see the weight. It means we have given us something number of weight, w1, w2, w3, up to dot 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 wm. Yeah, then next you can see submission and bias. Yeah, so definitely it would be required a submission of this x, w, that like you can see the equation like sigma I equal to 1 to m, where you can see that x and w, which is going to be a multiply, and with some bias, something will be the fixed value over there. Maybe. Why? Because sometimes weight will be 0 and this value also going to be a 0. Then it will never be happen with the 0 value. So that's why we have added something, a bias value, for that a basic understanding. And a little bit move out with this equation, like f of x, you can see that 1 and 0. So if sigma wx plus b, which is greater or equal to 0, and another side you can say is the less than 0. So like activation function, like it be like represented in the like a symbolic manner that we want to like declare it over here. And last, that part about is y, output, our structure. Okay, input and output means as we have already seen in the first my diagram, input and output, and between the header layer that we have seen. But the number of mathematical calculation that could be happen over here, you can see that. Okay, now number of weight which is assigned to individually, as well as bias is going to be added, as well as activation function that you can see over there. So at the end, if I want to like mention it, you can see that as in the previous diagram what we have seen, input layer, these all come up into the our hidden layer. Yes, that I would like to call as a I, H, sorry, this is I, and at the end you can see this one, this is going to be our O, it means output layer. 1, 2, and this one is 3. Okay, so previous diagram, very easy to understand, like input layer, output layer, and between that part hidden layer. But number of things which will be happen in between those part, actually a number of calculations will be there, weight, number of weight which is going to be assigned over there, bias value will be there, many calculations will be there, bias value that we have mentioned, and any activation function that we have mentioned here. You can see this one part. Okay, so now as in mathematically, that if we can see over there, input and output, and between this hidden part. Okay, so this is the actually a neuron network that we are talking about actually. Okay, so a little bit move on with the presentation. Yes, again a little bit more clarification with this same one, with the same diagram, represent in something little bit different manner or different part, I can say. So not as much can different it. These are the our inputs, x1, x3, xn. These are the parts you can see. And as you can see here, the x will be there. Now we are talking about W. W, it means what? Weight which is going to be assigned. You can see this one, 1, 2, 3 up to n. Okay, these are the like combination, 1 to 1 connected over there. You can see this one. Yeah. And third section, that is like B, which is the meaning of this bias. You can see that is the basic value that is mentioned as a 1. So you can see that in some of the way value will be considered as 0, then definitely multiplication is going to be 0. So that's why we are taking the bias as any fixed value 1, or it may be anything, but by default or by generally we are referring with the 1 value. Okay, and like a summarization of this part of this equation, and then mentioning the threshold unit means activation function as we have discussed here. Okay, and these are the our output part. Okay, so these are the our input. This is the between a calculative part, as in hidden layer you can see as a calculation part, and this is the output layer. Okay, and below we can see that like as I mentioned that W12 up to n weight, and x1 1 to n that is input, and B stands for the bias as we have discussed here. Okay, so I think that critically of this diagram, that easily manner that we can see over there, easy to understand through this a single neuron or a single neuron, like how they are actually calculated or how they are actually working in this part actually. Yes. Yeah, then simplified with a little bit more hard, like 2 neuron if we are talking about that. Okay, so y1 and y2 simplified with, like you can see that y1 will be there and the another neuron like it's a y2. Okay, so like similarly these are the number of input x1, x2 and x8 that simplified here what we have said up to the 1 to n that we are talking about. But in a minimized level or minimum level that we are talking about, there only the 3 input layer will be there, and 2 will be the only neuron, y1 and y2. So you can see that each node which is connected one to another. So the equation would be like something here. You can see 1 1 multiply x1, 1 2, x2, 1 3, x3, and similarly for the second one y2. Okay, this one you can see 1 2, this one 1 2, this one x3 1 and 2. Yeah. So something in the presentation of the array manner, like we know about this part, like neuron as a y1 and second neuron as a y2. So it given a following equation. You can see that this one 1 1 1 2 1 3, this part cross this x1 x2 x3 become this equation. Like you can do the multiplication of this part through the array, like basic something part, something simplification of that part, that little bit move ahead with the single one x1 x2 x3, and these are the part, and y1 and y2. So something a very basic calculative part or very mathematically presentation, that you can represent it as a neuron as y1 and y2, the whole layer. Okay, so similarly the same thing that we have described, like input and more than one layer, as we have discussed, hidden layer 1 and 2, and the third, that is output part. Yeah, so output, await n minus 1, and the input part. So that is basically described as your whole layer. So whenever you start or something discussion about the neural network, what it is actually, itself a big calculation or itself a separate continuation or the mathematically abstraction about that part actually in this in the field of this machine learning, as well as especially into this deep learning era. Yes, and now move ahead with this activation function. So before starting with this activation function, that it decide whether a neuron should be activated or not. So this means that will decide whether the neuron's input to the network is too important or not. So the process of prediction using the simpler mathematical operation. The role of the activation function is to derive the output from the several input paths into the number of nodes. So basically activation functions are a critical part to design of the neural network. It depending on the nature and the intensity of this input signal, the brain processes them and decides whether the neuron should be activated or far or not. It means like, so you can say that the choice of activation function in this hidden layer will control how well the network model learn the training of the data sets. Secondary part, the choice of activation function. Yeah, that is again the output layer will define the type of prediction and the model can we are using that we are making over there. Yes, as such, a careful choice of activation function must be made each deep learning project. Yeah. So whenever we are talking about this deep learning, it must be required to choose the best activation function at the same time of this hidden layer to working with this input layer and working with this output layer. Okay, so a little bit more ahead with the topic about this activation function. So there are the number of activation function which is available there. Binary step function, linear, sigmoid, 10H, restless ReLLU or leaky ReLLU, parameter sized, exponential linear unit, swish, and softmax. We'll just go through it and just try to understand about that one by one. Like firstly talk about binary step function. So basically binary step that come to our mind, that what we have activation function would be a threshold based on a classifier whether or not the neuron should be activated based on the value from the linear transformation. So basically it depends on the threshold value and whether decide it should be activated or not. So through the diagrammatically, if I want to present it, you can see this diagram, like this something value will be mentioned over there and something will be the pick point that is mentioning over there like dot. So input fed to be the activation function which is compared to the a certain threshold. Secondary part. If this input is greater than, then neuron is activated. Else it is deactivated. It means just a basic condition like f of x is equal to 1. Then x greater or equal to 0. And if it is 0, then it would be mentioned as the x less than 0. Okay. So this is about the binary step function where this output is not passed onto the next hidden layer, that we want to transfer it from the one hidden layer to the next hidden layer. Yeah, as I already told you about this equation actually. Yeah, f of x, you can see that if it is 0, then x less than 0. But if it is 1, then it should be mentioning as a x greater or equal to 0. Okay, so cannot be provided the multi-value output or cannot be used for the multi-class classification problem. Okay, so yeah, definitely the number of classification will be there and some of the limitations of that particular part. So multi-class classification problem, then it cannot be provided the multiple value for the output. It's just only working with the 0 and 1. These are the something limitation of that part of this binary state function. So gradient of the state function is 0, while the hindrance and the back propagation of the process. Yeah, next that we're talking about a learning activation function. Sorry, linear. It's my mistake. Yeah. So a linear activation function, that is basically also known as a no activation or identity of the function. Like multiplied cross 1.0, you can mention it as well, like where the activation is proportional to that given input. You can see that. The simply go through the diagram, like it's proportionally working with this both the way axis, like x as well as this are y axis. That would be like prefer like with this way. This would be like our x axis. Yeah, so it's just a proportional to our input. So it doesn't do anything about the weighted of the sum of the input, and simply fit the value of that will be given over there. So instead of a binary function, we can use a linear function. We can define in this particular manner. The compared to the previous one, give something more reliability. Yes. So definitely that need to be discussion about the equation. You can see that if it is something good, then definitely something limitation over there also. The two major problem. The first one, not possible to use back propagation. We cannot be back propagate over here. And second one, that is a no relation to the input of the x. But again, like all the layers of the neural network which call up, so if a linear activation function is used, no matter a number of the layer in the neural network. So when it is come up with the more than one layer, then it doesn't matter that like how many number of layer that we are going to use here. So the last layer will be still a linear function of the first layer. The last and fun which is connected to which one other. So that equation like f of x, where we have to say that if it is 0, then it's like greater than 0, and 1, then it's greater or equal to 0. That similarly you can see that f of x is equal to x, as we can mention that like neural network into just a one layer. Okay, so move ahead with binary, then after linear active function, then yes, next that is non-linear activation function. So basically it's shown above a simply a linear regression model, because it's a limited power as well as does not allow the model to create any complex mapping between this input as well as into the output. So basically using for the complex mapping and solve the following limitation as the linear activation function, which is not be able to do that functions. That first major issue about the back propagation, that we cannot be able to perform it in the linear activation function, that would be easily performed through this allow a back propagation. So derivative function would be related to the input and possible to go back and understand the weight in the input can be provided as a better prediction. Yeah, definitely a back propagation will be there. Then number of layer will be there. That is going to be doesn't matter. A number of 10 layer, 15 layer, 20 layer will be there. The number of layer which is connected to one another, and this input neuron that can be provide something a better prediction compared to this linear activation. Yeah, a set of multiple layer of this neuron. as the output. So the non-linear combination of input base through the multiple layer, and it can be represented as a functional computation in a neural network. So definitely we'll just go through the one by one. Like first that is binary strip, that facing some issues with the limit function. That next one is the linear activation function. Third that is the linear activation function. So each and every function has its own importance, its own something limitations as well as advantage of the using of that part in a deep learning. Move on with the next one, sigmoid or the logistic activation.
By now,
You can see
understand
for one.
that
So, sigmoid curve.
I will be offline.
Kindly make
Also there
sure
in this group. Prakriti, just put in your unofficial group also that everybody should be present on Monday at 9:30 for the lectures physically, right? I have already dropped the message, right? And
kindly
for
my participant. It's humble request.
your midterm exams also. Did you receive?
Hello.
Yes, ma'am. Yes, okay. So I'll be also posting it today, but then I think the CR.
Aparna, hello. Thank you so much for this help. Yeah, so moving ahead with the sigmoid logistic activation function. Yeah, the larger the input, a more positive and closer. That value will be like 1.0 or the 0. That the range between that part 0 and 1. You can see this one 0 and the another part that is 1. So the smaller the input and more the negative part, and the closer the output will be the 0.0 as we can shown over there, like 1 upon 1 plus e raised to minus x. You can see that part. So then this sigmoid transfer the value between the range of 0 and 1 and the mathematically expression of this sigmoid as you can see here. So this is about the sigmoid, or you can say as I mentioned as the logistic activation function. So where it is going to be used now, like if we talk about like, so it is a use for the model where we have a predict probability. So something prediction like yes or no, like the person having a disease, yes or no is yes or no, like would be the answer will be that, and probability of anything exist, yes or no, that only between the range of 0 and 1, that sigmoid is the right choice because of that its range 0 to 1. Like what is the possibility of that having a disease of that person is like 0 0.7, 0 0.8, then it will be suffering with the disease or the 1. Or if it is like going with 0, then like will prefer it, like it may be or may not be like suffering with that disease. Yeah. So it's a smooth gradient, that means preventing a jump into the output value and escape for the sigmoid activation function. Yeah. So this function are discussed as like f dash x is equal to sigmoid of x multiplication 1 minus sigmoid x. Okay, so this is about the logistic sigmoid function, where one of the most widely used into the functions. Yes, so moving ahead with the one more activation function, that 10h, it means hyperbolic. If you can see only this part, yeah, 1/4 of this one, that it would be like walking or behaving like a the previous one, like this name is sigmoid, and now the completely quadrant if you want to cover, then it may be presenting as this one 10h curve. So it's a S shape. The range previous one that is 0 to 1, and now we have covered with the minus 1 also. Okay, so minus 1 to 1, not including the 0 to 1, but it is covered with the minus 1 to 1. You can see that the 4 quadrant, this 1, 2, 2 and 3, 4, it should be covered, and the previous one you can see that is only performing with the only one quadrant 0 to 1 only, and here you can see 1, 2, 3, 4, 4 quadrant is going to be covered. Yeah, so the closer output will be the 1.0, and the minimum that would be like minus 1.0, that you can mention it. Yeah, closer output, yeah, you can see that this one. Okay, so like with the previous one, it is very easy to understand sigmoid and tan h. Like sigmoid that will be 0 to 1, tan h that will be minus 1 to 1. Okay, So sigmoid that mentioned as a 1 in both the case, like one will be the closure of the output, and in another part like 10h that is -1, and in the sigmoid that is basically belong with 0 1 0 to 1. Yeah. So sigmoid, then 10h function, hyperbolic that is basically known as a hyperbolic tangent activation function. Yeah. So if we can use this 10h, then it's a zero centered. You can see into this diagram actually. Strongly we can represent that part actually. I'll be a little bit erase this one first of all. Yeah. Now you can see. Sorry. Yeah. Take a pen. So it's a 0. That is 1. That is -1. And the fourth quadrant 1, 2, 3, and the fourth quadrant. Okay. You can see that. Strongly negative, neutral, and strongly positive. You can see that. So minus between -1, 2, and the 0 is very close to that 8. And centric of the data and makes the learning for the next layer much easier. You can see this one, yeah. So through this, you can easily understand for the 10h as well as sigmoid. So this hidden layer come out to be the 0 or very close to it, and have an centric data and makes a learning for the next layer much easier. And mathematically it can be represented like f of x e raised to x minus e raised to minus x, and e raised to x plus e raised to minus x. So this is the basic function for the 10h function. Yeah, moving ahead with the rectified linear unit, next activation function. So it's basically a derivative function and allow it with the back propagation, and simultaneously allowing with the computationally efficiently, means give something better outcome with the previous one. So the main catch here is that rectified linear unit doesn't activate all the neurons at the same time, but that one only be deactivated if the output of the linear transformation that would be like less than 0. Okay, so doesn't have the active at all the neurons at the same time, but the if the output of the linear transformation is less than 0, then it would be going to be activated. Mathematically, yes, you can see here like something looking differently with the previous two one. Yes, this one is the quadrant, like you can see this one is the square, and these are the proportional to the input and output. F of x equal to max 0 x. Yeah. So this basically known as the rectified linear unit. Right. Yeah, again, advantage if we can talk the far more computationally efficient compared to the sigmoid and 10h function, and convergence of a gradient descent toward the global minimum of a loss function, and dt is linear and non-saturating property. A leaky ReLU is just a basic, a part of this ReLU, rectified linear unit. So nothing will be the change. You can the small changes as you can small positive slope. In previous one it is like something this and goes with this, but here you can say these are the some extra given like something positive slope in the negative area. In like previous what we have seen in something like in the quite different. And here you can see something will be the positive part. You can see compared to this horizontal. So it can be like represented at f of x max 0.1x comma x. So like advantages like that we are talking about compared with this ReLU, rectified linear unit. So it does not enable the back propagation even for negative input value. Not given a back propagation as well as negative input value. Secondary, a minor modification for the negative input value, and the gradient of the left side of the graph come out to the non-zero value. Okay, and it would no longer encounter dead neuron in that particular region. Okay, so that is about ReLU and leaky ReLU, rectified linear unit. Leaky linear rectified linear unit. Yeah. Yes, moving ahead. Third, that is something a little bit different with the previous one, like parametric ReLU. Again, just a part of that, you can see that a negative part of the function as an argument. You can see this one, like slope in the negative direction. Previous one into the positive, and the this one is into the something negative in that part. Yeah, so it's another variant of ReLU aimed to solve the problems of the gradients becoming zero from the left half of the axis. You can see this one and second, that is this one. So basically, this function provides the slope of the negative part of a function as an argument a. So the performing this back propagation most appropriate value in the previous one, that's not going to be allowed with the performing this back propagation, and here it is providing this back propagation. The most appropriate value as an a is learned. Say f of y is equal to ay, you can see, and f of y is equal to y. This for the y axis. So the equation, something would like to see here, you can see f of x max a of x and x. So a is the slope parameter for the negative values. So the ReLU function is used when the leaky ReLU function still fail to solving the problem of this dead neuron. When there is a performing about the dead neuron, that whether this parameters ReLU rectified linear unit is going to be performed that dead neuron, and relevant information is not successfully passed to the particular next layer. Again, there's a limitation. It may perform a differently for the more different problem depending upon the value of the slope parameter a. Next, that is about exponential linear unit ELU function. So something a slope into the negative part. You can see this one. This is the highlighted part. Yeah, slope of the negative part of this function. Yes, the variant of the ReLU that modify the slope of the negative part of the function, that allowed curve to define the negative values unlike the leaky ReLU and parametric ReLU, a function with a straight line, where you can see this one the straight line as it is performing like a ReLU as we have mentioned, rectified linear unit, and the parametric ReLU as the straight line, leaky and the parametric and the ReLU which having this straight line. Okay, so that is about the explanation. It nothing should be different, but a little bit a small quite differently performing with something differently performed compared to this leaky ReLU, parametric ReLU and the ReLU only. So the values of this equation, like greater or equal to 0, it would be less than 0, x and alpha e raised to x minus 1. So it becomes a smooth slowly equal to minus alpha, where ReLU is sharply smoothest, as well as introducing a long curve for the long negative value for this input, weight and the bias into the right direction. So again, there is a limitation, as like we can discuss, increase the computational time, and the no learning of the a value take place exploding this gradient problem. This exponential function operation include the no learning of this a value, which take place excluding the gradient of the problem. Soft max. Next one, that is soft max. You can see into the on the first half of this quadrant. Basically, the quadrant will be something look like this. If you are talking about positive of the first upper side, and another side, you can see. So excluding now and the logistic activation function, and the values like exponential and the j exponential. So right, Dr. Hallen, please, it's humble request. Dr. Hallen, Hello. Thank you very much. Yeah. Yeah. So moving on with the switch, where the self-gated activated function developed by the researchers at the Google. This activation function on a deep network that will be a various challenging domain in the image classification as well as the machine translation. So wherever you perform with the image classification as the machine translation, then it may be helpful to this switch function. So the equation something look like something here. X multiplication with a sigmoid X. Okay, so it can be like each and every function has something mathematically representation like X multiplication of the sigmoid X bounded below with the unbounded above. So this is about the switch that we have discussed here. So now there is a question for each and every mind. Like these are the number of activation function that we have seen, but what is the right way to choose the perfect one activation function for my prediction of the model, for my particular model that I want to train and I want to execute it? Yes. So RELV activation function that only be used into the hidden layer. You can see that for the hidden layer that we can use only RELV. Then move ahead with the sigmoid and logistic or the tanh function. It just a summarize of this all the activation function that again not be used in a hidden layer as that make the model more susceptible to problem during the training and due to the vanishing of the gradient. Then switch. The neural network have a depth greater than a 40 layer, a more than 40 layer that you are calculating in your prediction model. Then you can use this kind of something activation function that is basically known as a switch activation function. So something criteria will be there to choose or select this appropriate activation function. RELU, if you are talking about sigmoid, logistic, tanh, switch function. So each and every has some limitation or something fixed criteria that you can mention it over there. Yeah. Yeah, something a prediction problem that you can solve it. Like first one, regression. So linear activation functions will be there. Binder classification will be there. Then you can see sigmoid and the logistic activation functions there. And the next, multi-class classification. Then software you can use it and multi-level classification. Then sigmoid will be the best of the opportunity. So this activation function used into the hidden layer is typically chosen based on the type of neural network of the architecture. Neural network, as already in the starting of the part we have discussed, neural network, single neural network, ANN, biological neural, mathematical neural. Now, how they are connected with this activation function that we come to know with this after this completion of this activation function, and how the all the activation function 9 up to till that we have seen that all the activation function how they are connected with the previous one. Previous one it means all the activation function how they relate with this all the neural network which is applicable for the which prediction layer. So this convolution neural network that is basically use the RELU activation function. tanh or sigmoid that is basically recurrent neural network. You can see that. Yeah. So network type that if you want to say then a multi-layer perceptron, convolutional neural network, recurrent neural network. Again, multi-layer if you're talking about RELU, convolution RELU you can use it, and recurrent RNN if you're talking about sigmoid and the tanh activation function we can use it. Okay, so these are the network type where you can see that. Multi-layer perceptron, convolutional neural network, and the recurrent neural network. And we can see that various activation functions will be there. Next, yeah. So I would like to summarize over here. So at its core, learning relies on an iterative method to teach machines to initiate the human intelligence. ANN carries out with the iterative method throughout the several hierarchy of the level. The initial level, which help the machine learn simple information, and level increase the information keep building. So with each new level of the machine, pick up the further information and combining with it had the learn in the last level. So at the end of the process, The system gathers at the final piece of information which could be compound to input and the information process throughout the stack of hierarchy and assembles to complex logical thinking. So I'm not suggesting that the neural networks are easy, but you need to be expert to make this thing work, and expertise serve you across the broader spectrum of these applications. So in a sense, all of the effort that previously went to in a feature design now goes to architecture design and lots of the function design. Optimization schema design. The manual labor has been raised to a high level of abstraction that a Windows standards be delivered by this Stanfano Seto. So yeah, thank you. Thank you very much. Yes, any suggestions, any question would be appreciable.
Thank you, Dr. Gandhi. It's really a privilege actually to see you online.
Thank you. Thank you so
And
much.
we have the next speaker, Dr. Srinivaslu from Liberia.
It's a wonderful opportunity. Yes.
Yes. He has also delivered many expert lectures like you.
I hope I have not consumed much more time here actually.
No. You are as per the time only.
Okay, thank you very much.
It's a real privilege, Dr. Gandhi. We'll meet you again.
Yeah, definitely. Sure, sir.
Thank you, sir. Have a nice day.
Okay, same to you, sir. Have a great day ahead to all the team members also.